All right, so I'm going to kick things off with an introduction. What is distribution system planning? What is the distribution system even? Why is it important? A framework that was recently developed for how to work through this for decision making, integrating state policy objectives into planning. What are the data and analyses that utilities can provide you, all of you in the room, and other stakeholders? And some new work we've done on economic evaluation of grid modernization investments and other expenditures. And then Natalie is going to talk about brand new work on cost recovery for grid modernization investments, a really important topic. For each session, we will cover questions that you and states can ask and actions states can take. There's also going to be resources for more information and Q&A after each one. So let's start off with a better understanding across the room of what is the distribution system. So I've included a couple drawings. The top drawing shows what is connected to the utility poles. So we have insulators that protect the wires from the poles, the primary wires or conductors that carry electricity from the substation, the transformers that step down that voltage to a level that's appropriate for secondary wires that carry that lower voltage electricity from this transformer to homes and businesses, and fuses that can interrupt the power when there's an overcurrent in the line. So that's the top drawing. The bottom drawing shows substation components going from left to right. There are transformers that convert power from the high voltage system at the transmission or subtransmission level to lower voltage at the distribution system level. There are regulators that maintain voltage within a specified range. There are capacitors that adjust the voltage to maintain system efficiency. There are capacitors that adjust voltage. The circuit breakers protect transformers by interrupting current when a line fault is detected, and bus work, which is made up of conductors that connect electrical equipment. So electricity planning writ large occurs at all levels of the system. In every jurisdiction, utilities conduct distribution planning to assess the physical and operational changes for local grids needed for safe and reliable service. So typically it's an annual process with a 1 or 2 year planning horizon. There's also a longer term capital plan for identified distribution solutions. And that's typically over a 5 to 10 year period, updated every 1 to 3 years. So the short-term plans are actually drawing from those long-term plans. For vertically integrated utilities across the country, there's integrated resource planning that identifies future investments to meet bulk power system needs at least cost, considering the risk that cost might be different than you think. These plans are increasingly accounting for distributed resources which are connected to the distribution system. IRPs can consider scenarios for loads and distributed resources and impacts on the need for and the timing of utility resource investments. Transmission planning is identifying future expansion needs and options for the high voltage system. While regional transmission planning venues tend to dominate the conversation, it's important for integrated resource plans by utilities to consider transmission as a resource to bring in market power from other regions. So the Energy Systems Integration Group through Berkeley Lab will publish soon a guidebook that will cover integrated system planning, coordinating across all these levels: generation, transmission, distribution, and customer loads and resources. So look for that soon. All right, so when we talk about integrated system planning, integrated distribution system planning, what are we talking about? So it provides a decision framework for developing long-term grid investment strategies, state and local goals, objectives, and priorities, as well as consumers' needs and evolution at the grid edge. These state goals and objectives define the long-term high-level outcomes for grid planning. That determines the grid capabilities that are needed, which in turn establishes the distribution system functionality and system requirements. So objectives, all the traditional ones you're familiar with: safe and reliable service, affordability, and more recent aims to address new resilience threats, for example, to use local resources, to reduce air pollution, to improve utilization of distribution assets, and better integrate the distributed resources that consumers have at their. The thing is, it's a transparent, objectives-based process that's informed by stakeholders, very much like integrated resource plans we've been doing for decades in this country. So why are states increasingly getting involved in distribution system planning? Because utilities have always done this, right? They just haven't been sharing their work as much. So I think the numbers say it all. Here's the latest chart from the Edison Electric Institute showing capital expenditures by just investor-owned utilities. This doesn't even include the rural electric co-ops or public power. So distribution system investments account for the largest part of CapEx, about a third, and the estimated cost for 2024 is $59.7 billion. So what are the potential benefits from an improved planning process? Well, I think first and foremost, better oversight of those capital investments, as well as operation and maintenance expenses that were not included in that total. When utilities file publicly their distribution plans, they're making transparent their planned investments in a holistic way before they show up individually in rate cases over time. So you have a better picture of total costs and how things fit together. And they provide opportunities for meaningful engagement with stakeholders and utility regulators to improve outcomes. They're considering uncertainties under a range of possible futures, or what we call scenarios, considering all solutions, including distributed resources, to try to get to that least cost, least risk balance, and enabling consumers and third-party providers to propose grid solutions and participate in providing grid services. So here are some example strategies for translating policy goals into planning guidance. First, states can identify their priorities for distribution system planning and ultimately implementation of the plan. For example, the Maine legislature required that the Public Utility Commission identify the priorities that utilities should include in what they're calling an integrated grid plan to assist in the cost-effective transition to a clean, affordable, and reliable electric grid. And they left it to the PUC to drill down into this. So the PUC identified 3 goals: improve reliability and resilience while maintaining affordability and achieving the state's climate goals, improve data quality and integrity, promote flexible management of consumers' resources and energy consumption. So states can ask utilities to provide information on the current status of their distribution system and the planning activities that they conduct. States can get input from experts and stakeholders that could include, for example, things like opening up an informational proceeding to gather input and increase understanding, and engaging communities that the utilities serve. States often will host working groups, and this could be hosted by a state energy office. It's not necessarily at a PUC. I think state energy offices are also well positioned for this. And they can make recommendations to utilities on draft plans before filing with the Public Utility Commission. An example is in Massachusetts. So how do you know whether you've been successful in translating your state's policy goals and objectives into guidance for grid planning? Well, these are, this is my perspective. So first, the utility is actually asking for input and is reflecting that input in its plans. Ideally, the utility summarizes all the comments it's received and their responses and how they took in that feedback in the actual plan, for example, in an appendix. And it really specifies the actions that they took. Utilities can consider all potential solutions to meet grid needs using robust and transparent analyses. And that includes all kinds of options: traditional distribution investments, grid mod technologies, and non-wires alternatives like storage and demand flexibility. And then the filed distribution plans will actually be very clear and show you a roadmap for the utility's planned grid investments over time, as well as the processes designed to achieve your state's policy goals and objectives, and including their utility's own priorities and timelines. This next point is an important one, actually. Utility plans are actually well organized and documented. I've heard from many states across the country. I'm getting thousands of pages. It's really impossible to get through. I'm not sure how useful it is. They should specify how the utility met the regulatory requirements and explain how they're coordinated with the other types of state and utility plans that Grace will talk about later today. And ultimately, do they provide useful information for regulators and stakeholders? I also think that you know you're successful if the regulators are providing some kind of feedback to utilities on their filed plans. That doesn't mean that they have to approve them. In fact, that may not be the best thing. You might want to reserve all that determination of prudence for rate cases. But in order for utilities, I think, to invest in some of these technologies that we need to achieve state goals and maintain reliability and resilience with increasing threats of all kinds, I think they need some kind of feedback from regulators on their proposed technology roadmap. The planning process should facilitate cost recovery of prudent utility investments in grid modernization, as well as integration and use of distributed resources. Utility cost recovery requests should be clearly tied to achieving state goals and objectives and utility priorities, and clearly tied to the plan. And finally, utilities should be tracking and reporting on progress for implementing the plans that they file. And that includes presentations at public meetings. All right, so we've developed an interactive framework funded by the US Department of Energy that walks through a stakeholder-informed process for distribution planning. This is where, usually you say, put your phones away. Take your phones out and scan this QR code if you want to follow along. So this diagram is really just showing the big picture. Everything is flowing from the top. Everything is flowing from your state and local goals and planning objectives at the top of the diagram. So they're sort of like big chunk color boxes. So the blue box indicates technical analyses like locational forecasts for loads and distributed resources and scenario analyses for those. Assessing the current state of the distribution system, term distribution, kinds of other distribution analyses like hosting capacity and locational value of distributed resources, which we'll be talking about today. Mic is not great. All right, that was the blue box. Is this better? All right. The gray box represents sourcing a subset of grid solutions from distributed resources. That could be through the 3 Ps, through pricing, which is time-varying pricing typically, programs, and procurements. And finally, the green box at the bottom indicates the resulting distribution plans. So each step of the framework describes what happens during a particular part of the process, why it's important, stakeholder roles and responsibilities, and current and emerging best practices. We also provide a flow chart, summary of analytical tools, and an annotated list of resources for more information. So I'm going to briefly go through the topics you see here. Again, if you snap on this QR code, you can follow along and explore further our interactive framework online. All right, so at the top of the diagram, one of the things that we cover in there is under state and local policy goals and planning objectives are the stakeholder engagement processes. So this involves participation by a wide range of interested parties to provide feedback on the objectives, the inputs, methods, scenarios, and priority investments. In other words, everything, in my view. And I think this is throughout the process. This is upfront when you're developing your requirements. Natalie will be talking about this later, throughout the entire process of developing these inputs and assumptions and the methods, and then reviewing the results. So next up, really important, forecasting. So we've got really granular in terms of time and space forecast, their projections of loads and distributed resources at the distribution substation, at the feeder levels, and that provides the information that's needed to inform the type and timing of distribution system investments that are needed. And we consider potential changes to loads due to what call load modifiers, such as various types of distributed resources, whether it's energy efficiency, demand flexibility, you name it. Scenario analyses are really nascent in distribution planning. We've used them for a long time in other forms of planning for transmission and for integrated resource plans, but we've got a lot of work to do here. And there's a new report by EPRI, the Electric Power Research Institute, that I think is quite good, that I think I referenced at the back. So scenario analyses are assessing the potential impacts of various plausible future events. And that informs the kind of flexibility you need to change gears as you are actually implementing your plan, and test the plan as how robust is it under different conditions. So your distribution assessment evaluates the condition of the assets, all kinds, transformers, what have you, and their operational performance with respect to planning criteria and standards, including for resilience and reliability. So many of you are familiar with some of these analyses, hopefully. So the threat-based risk assessment is identifying very specific threats of all kinds, natural and not so natural, to both assets and processes, and categorizes the vulnerability levels based on the consequence. So for example, customer interruptions and damage to the grid. A worst performing circuits analysis is something many states require utilities to file annually and report on at meetings and have discussion. This is where you're examining the outage data and you're developing a list of circuits with the worst performance with respect to reliability. And you're assessing the potential root cause and identifying mitigation strategies to reduce the duration or the frequency of outages, or both. And then a really fundamental part of the entire distribution planning process is focusing on how do you manage all of your distribution system assets. So it's managing that physical infrastructure for delivering electric service, which includes a systematic analysis of the condition and performance of these physical grid assets. All right, so this is my little commercial break for trying to fold in resilience, grid resilience planning into what we're calling integrated distribution system planning. This is really nascent. We've got a report underway now about this topic. And there are really two pieces. I know it's hard to read. Hopefully you're looking at the slides that you've downloaded online. So at the very top of the diagram where we're talking about state objectives, that's where you've got the community engagement with respect to priorities, vulnerable populations, critical infrastructure needs, and emergency responder coordination. And you've got your state and regional planning, where you defined your critical facilities. You've got your climate studies, emergency services planning, and policy direction on how you're going to address specific populations. And then in the black box, where we're talking about all of the distribution system assessment analyses for reliability and resilience, a lot of the things I just talked about in terms of asset management and vulnerability assessment, you've got also your technical guidance. You're getting input from, for example, climate experts, might be at your universities, at your state level. And you've also got your resilience plan, where you're prioritizing solutions for the assets that you've identified as being vulnerable, as well as your processes. And you've also got your standards updated to address your resilience requirements, and your performance metrics are reported annually. So in my view, having this separate from a distribution plan doesn't make a whole lot of sense. You really want to see all of these investments together in place and have feedback on all that together. All right, so the next part of the framework is cost effectiveness. And for some reason, it seems to have been like a separate process, but really it's baked into throughout, we'll talk about that in a moment, throughout the process. So you've got your near and long-term planning. You're establishing that utility strategy for capital investments and other O&M expenses to address your identified grid needs. Typically, it's over a 10-year period these days. And then your near-term plans drawing from the long-term plan with greater specificity over the next, let's say 3-5 years. So that cost effectiveness evaluation that should really run throughout is assessing the benefits and costs of the investments to determine the best course of action to meet your grid needs. And the reality is there are a lot of objectives, and it's an exercise of how many objectives you can achieve through this investment or expenditure. You're ideally like knocking off a bunch at once. So it's a set of methods to prioritize expenditures that provides the greatest value toward meeting your goals, customer needs, your requirements, and utility criteria. And then the coordinated planning that Grace will talk about later is harmonizing all the outputs from traditionally siloed processes, for example, by enhancing the consistency of assumptions and methods. And then the term integrated planning really is more about unifying the processes to streamline the analyses. All right. The distribution system analyses box, that includes all of the engineering, the economic and technical studies. And Cody will be talking about this more. So hosting capacity analyses, that's identifying how much distributed resources like solar or EV charging that you could put in, that you can interconnect without adversely affecting power quality or reliability under existing conditions. So without any infrastructure upgrades. The value of distributed resources is based on their capability to provide grid services. And Cody will also talk about that later today. And interconnection, an engineering definition is it's the result of adding a distributed energy resource to a distribution system, but the term also can refer to the technical standards, the procedural standards, and the legal requirements for interconnection, as well as the physical location. So that term is really quite broad. All right, now we get down to the grid mod box, and we're establishing that technology roadmap for all your capital investments, your programs, your processes, and all your other expenditures. So the grid mod plan is informed by this distribution system plan, and ideally are filed together. And what we have seen is states that had, for example, a grid modernization plan filing requirement. They're now baking that into and requiring the utilities to file them together because it makes sense. Examples are, for example, Minnesota and New Mexico in their proposed regs. So this distribution investment strategy and implementation plan, it's providing that roadmap for meeting the multiple objectives in an affordable way over the planning horizon. It demonstrates how the utility translates planning objectives into their decisions for spending. It's describing the near-term needs in the context of that long-term plan. And these functional requirements analyses, they're all the business processes within the utility to address the specific grid needs. All right, and finally, some of these distribution system strategies can be sourced through on-site distributed resources or utility-owned distributed resources. For example, at the end of the line, you might have some battery storage, for example. So that includes all the programs, procurements, and pricing, the 3 Ps. So, for example, you can geo-target your existing energy efficiency programs or your existing demand response programs or even solar and storage programs. You can focus your incentives on specific locations on the grid that are problematic, or you can raise the level of the incentive for certain areas because they're more valuable to have those types of resources located there if they can meet the locational and time needs. When we talk about procurements, we're talking about requests for proposals, solicitations to ask for a customer or third-party owned alternatives that can defer some types of distribution system needs. And pricing, we covered this in a paper by a colleague of mine, JP Carballo, and this is about adapting or designing new tariffs for utility customers to include location and time-specific distribution system benefits of distributed resources. And this is very nascent. We need to make more progress there. Okay, so I'm gonna talk about how do you get the data and analysis that utilities have, why is it important? So this published report describes how utilities use the data in planning and how data analyses actually affect their decisions. So we interviewed utilities, regulators, state energy offices, and we reviewed a lot of utility distribution system plans. We published also a complementary report on the resilience side, and these resources are in the back of the deck. So the report covers 11 data categories that are listed here, and we used an Excel-based data collection tool that we posted on our publication page. So you can download that Excel file and adapt it however you want, and use it as a tool to track what information might be valuable to your state energy office, to your consumer advocate office, or at the PUC. So I just wanted to provide one example of the 11 categories to give you a high-level view of what's in the report. So I'm using this hosting capacity example. Again, that's the amount of distributed resources you can connect without making any upgrades to the system. And this analysis is modeling, again, the existing conditions, and it's simulating power flow at various levels of distributed resources, whether it's generation storage or new loads like EV charging. So utilities are using hosting capacity in several ways. They can use it to determine if detailed studies are needed for interconnection requests to make that process a little bit more expedited. They can identify locations and causes of constraints on the system and assess options to mitigate that. So the way that we've structured the report is we have sort of key input data and outputs. So the key input data in this case that utilities can share in the distribution planning process are the analytical frameworks, the attributes of the infrastructure, the load characteristics, and the capacity of DERs that can interconnect at various locations. The outputs, or the DER capacity that's actually already queued up or at that location, and the outputs that utilities can share are the estimates of the hosting capacity, whether it's generation like solar, it's load, like EV charging, which can be both directions too, or storage, and all the results of the mitigation analyses. So each section of the report also includes best practices for each of the 11 categories in the report, and these are the best practices here. I'll leave that for you to read later. We also recently published a report on economic evaluation for grid modernization investments, and it follows very closely this process for distribution system planning. So in red, I'm showing here, circling in red, all of the places where the economic valuation really comes into play. So there are three core principles here. There's transparency and consistency in how utilities assess and show the relationship between the proposed grid solutions, the identified grid needs, and the related state objectives. It's also, second one is credible data, and that can mean independent sources and balanced sources that reflect a time frame that's relevant for the analysis. And third is a holistic view that includes all the supporting analyses of the grid needs and identifying the benefits and costs in both monetary terms and non-monetary terms. So the first step in the process is the clear expectations for distribution modernization through the lens of planning objectives and priorities. And next, the utility uses stakeholder-informed forecasts and scenarios to identify grid needs and assess uncertainties about their scale, scope, and timing. And then the utility identifies the proposed solutions for specific grid needs from a set of potential alternatives to address, again, these multiple objectives: affordability, reliability, resilience, other state objectives. And this step, importantly, is considering interdependencies of potential investments. Sometimes you need a base, rather expensive investment to get all of the capabilities and functionality that you need, and those are being invested over time. Also, these foundational investments, considering all the technology risks and uncertainties about the identified grid needs. So the result is this roadmap of expenditures over time. So next is the actual cost effectiveness screening. And finally is a prioritization step. You can't do everything all at once, and you can't, invest in everything. So how do you prioritize? And you're looking at each individual investment's contribution toward achieving the established objectives, including all the potential rate and bill impacts for customers. So I'm going to step back, go through each one. So here are examples of typical objectives and metrics that can be established through a stakeholder engaged process. For example, in the West, reducing wildfire risk, really big deal right now. Increasing grid capacity, improving the health of all the distribution system assets, or at least targeted set of assets and processes, and improving reliability and resilience in the face of all these additional threats. The second step is clearly describing the grid needs in terms of these objectives and metrics. So the output of this is called a grid needs assessment, and it identifies specific grid deficiencies. It describes each grid need with all of the engineering characteristics or functional requirements, as well as the timing. And it serves as the starting point for developing solutions to address each need. So potential solutions may be physical upgrades, as well as informational and operational technologies that can offer more insight, visibility, and control. So system improvements can include things like resilience investments, programmatic asset replacement, infrastructure upgrades, and grid technology investments, things like outage management systems, for example. The operational changes include things like system reconfiguration and adopting new design standards. Here you can see in Florida where they're increasing the standards for the winds that utility poles need to be able to tolerate because the wind levels are increasing. And things like non-wires alternatives, everything from time-varying rates to those geo-targeted customer programs I talked about, and the solicitations or procurements for services from customer-sited distributed resources. So cost-effectiveness screening is about assessing the value of an expenditure relative to the costs and determining an optimal course of action to meet the identified grid need. So this is just an initial step before prioritizing the potential solutions. So our report covers two common types of cost effectiveness evaluations for distribution modernization. The first type answers the question, what is the lowest reasonable cost to meet a safety, reliability, or other statutory or regulatory requirement? So this approach requires clear alignment and supporting engineer rationale for meeting the requirements. So the method might be applied to individual investments with interdependent relationships, like in order to be able to really get any value of the second investment, you've got to make the first investment. So that where the full value is realized only when all of these interdependent components are deployed. So that's one reason to pick this method, as well as having regulatory requirements. So you know you're going to have to do it anyway. What's the best way to do it? What's the least cost way to do it? The second type is traditional benefit cost analysis, which answers the question, will a specific investment or an interrelated group of grid expenditures enhance welfare for all or a subset of customers? So this is best used when you can monetize things, when you've got a dollar value of a proposed grid solution. It's really discrete, it's assignable, it's measurable, and it doesn't materially change if usage increases or decreases on the asset. All right, this final step, I know this is a messy slide. Hopefully you're looking at the slides online. So the final step is really about prioritizing. So how do you determine the optimal portfolio here for a specific time period? So again, the utility has always used this multi-objective decision analysis to prioritize its investments and all other expenditures. So the utility is assessing each proposed expenditure qualitatively, quantitatively, or both against each objective, and there are always metrics. So again, what can you ask the utility for? Ask them for the metrics. The priority ranking of the objective is typically reflected in a weighting factor, and that's applied to a total numerical score. The weighting is based on the contribution of each proposed solution to addressing each objective. So this slide on the left shows how Portland General Electric in Oregon does this. And it uses this final score for each solution, as well as its cost, to rank each expenditure from highest to lowest. There's another method, a value spend efficiency approach shown on the right, that determines the relative contribution of a potential grid solution to meeting a particular objective. For each alternative, the utility is dividing the total score by the cost to create a normalized efficiency score. So this is an example from Detroit Electric. All right, so that's what I have. And Natalie will talk about cost recovery for grid mod investments.
So this one goes forward? Yeah. Awesome, thank you. Good morning, everybody. My name's Natalie Mims. I'm also with Berkeley Lab, and as Lisa said, I'm going to talk about cost recovery for grid mod investments. So as Lisa, you'll see a lot of overlap between what I have in my slides and what Lisa identified as being good practices for integrated distribution system planning. So this link goes to an appendix to the slide decks that is much, much longer and has all of the details of the research that I'm going to talk about. And I just finished it last week, so it's hot off the presses. So it's very ugly. I apologize. It's all words. I'm going to try and fix it up at another time once you click on the link and see it. So for this research that we did, we looked at about 10 different utilities, grid mod, and rate case filings. And we looked at what type of grid modernization investments were being requested, and then if the commissions were approving them, and also what consumer advocates and PUC staff and sometime attorney generals were saying in their comments about the utilities requested grid modernization investments. And so this is the summary of our findings, and I'll go through these bullets in more detail as we go forward in the deck. But for the most part, there wasn't a lot of complete disapproval or approval. There was usually some shade of gray in between the utility got everything they wanted and the utility didn't get anything at all in terms of having their grid modernization investments approved. I do think it's important to note that just like when you're filling out a customer service survey, you're more typically going to do it when you're unhappy than when you're happy. And so I think a lot of the comments that we see are where the commission or staff are pointing out deficiencies or things they don't like about the applications, as opposed to applauding the utility for doing a great job at their job. So just keep that in mind. The rationale for grid mod investments focused on reliability, resilience, customer control, enabling achievement of state energy goals. Objectives to grid mod investments highlighted insufficient information in the utility filings on investment needs, costs, and timing of the technology and project, and I have several examples of that. Generally, the utility regulators were supporting proposals that had a strong link between grid mod, between the grid mod investment proposals, state policies, and electricity planning processes such as distribution system planning. They like robust cost-effective analysis that came through in comments, and also strong analysis of alternative investment options. And then some other topics that came up and themes that we came up as we were reviewing these applications were that timing of investments, optimization, transparency, and affordability were all mentioned by commissions and staff in their comments. So this is just a little bit of a summary of what the utilities' rationale were in their applications for their grid modernization investments. They're not too surprising. The investments are going to improve reliability and resilience and safety, reducing customer restoration time, proactively addressing grid needs, facilitating customer choice and control, very similar to enabling integration of DERs, supporting increased electrification, in particular if that's a state policy objective, improving operational efficiency, and assisting in achieving state energy goals. And some of those are overlapping, but they all go towards reliability, resilience, customer control, state energy policy. Some of the objections that we saw were improper, duplicative, or just outdated cost estimates was something that was commented on. Premature consideration of technology, insufficient explanation of the need for the project, inadequate or absent benefit cost analysis, proposing investments that are inconsistent with the planning objectives, inadequate consideration of alternative technologies, and failure to show that the project will be prudently implemented, in particular that you have enough staff to implement the portfolio of projects that you're proposing in the timeline that you're proposing. So I had this on my first slide, so I'm going to skip over it, but these are the three main reasons that we saw that the commissions approved the grid mod investments. So as I said, it wasn't that common for total approval or disapproval. There was usually some investments that got to move forward, some that didn't. My example I have here is from Xcel Energy. The PUC approved cost recovery for the fault location, isolation, and service restoration, but rejected their distributed intelligence project, which was also significantly more expensive. And then similar in Georgia, which we have some representatives from Georgia here today, the commission didn't approve Georgia Power's DERMS investment, Distributed Energy Resource Management System, but they did allow for the utility to begin spending money on some of the distributed energy resource investments that they wanted. So the commission, some of the examples where the commission supported investments because it was aligned with state energy goals are from California and New York and Illinois. So this first example is from California. The CPUC approved the Advanced Distribution Management System for Pacific Gas and Electric, and in particular because it was going to help advance their high DER future. And in New York, Orange and Rockland, the New York PSC approved their ADMS investment as well because it was going to enable achieving the state's clean energy requirements that they have. And similarly, in Illinois, the commission approved one of ComEd's investments because it aligned with the Clean Energy Jobs Act, which created the distribution system planning and a variety of other DER requirements. Commissions are interested in aligning proceedings. This is something that we're seeing pop up a little bit more and more. So for example, in Michigan, the commission required DTE to include descriptions about grid hardening and conversion, anticipated timelines, learnings from a technical conference that they required in their next filing. And so this is something that we've seen in the distribution system plan starting to pop up, where the commission is requiring additional action to be taken by the utility in the orders. And a lot of the time it talks about bringing in other processes, making sure that the assumptions that are being used are being aligned or at least discussed across different plans. Similarly, in Georgia, the commission required the utility to come back and report in their 2025 IRP about the need for the DERMS. And in Minnesota, the commission required the Xcel Energy to propose and discuss ways for the IDP process to inform financial and cost recovery issues in rate cases. So making that really explicit. An example of commissions supporting plans that had robust cost effectiveness analysis in North Carolina, Duke Energy Carolinas and Duke Energy Progress were two of the utilities we looked at. They have an appendix that they include in their plan that has a description of the project and pictures of it and cost benefit analysis and a variety of other pieces of information that are all pretty uniformly laid out. And the commission approved their grid modernization investments in part because of the cost effectiveness analysis. And then in Xcel in Minnesota, this was the example I gave on the fault location. The commission approved it because it was reasonable and it relied on sound assumptions and methodologies for their cost benefit analysis. Lack of cost effectiveness analysis was also cited by the commissions and was a reason for deferring approval. In Illinois, the commission rejected the utility's first multi-year integrated grid plans at the end of 2023 and have since approved them at the end of 2024. But they deferred this investment that they ultimately ended up approving, the REACTS program, which is advanced control and telemetry, because they failed to show that the investments are prudent, reasonable, and cost-effective. And then similarly, in Indiana, the Office of the Utility Commissioner, or the Office of the Utility Council, Andy, help me out. What does OUCC stand for? Anyhow, the consumer advocate in Indiana commented on their cost-benefit analysis for Duke Energy Indiana and pointed out that their incremental benefit calculation was overstated and that their estimates are understated because the information was quite old that they included in their plan. Robust analysis of alternatives is something that we're seeing as an emerging trend as well. In Illinois, again, this first example is from ComEd, again, for their Advanced Control and Telemetry program. This is from the ICC's first order where they rejected the plan. They didn't meaningfully seek and consider alternatives to a capital-intensive utility-built communications project. And so that was part of the justification for deferring that. And then in Maryland, Baltimore Gas and Electric was directed to provide internal management approval documentation that includes a review of alternatives. And so the commission actually approved this investment, but they told the utility to come back and make sure that they had better documentation on this and to provide that to staff shortly after the plan was approved. Commission and staff are interested in improved transparency. In Maryland, the commission pointed out that they encourage utilities to provide robust project-level detail, which is necessary to allowing stakeholders in the commission transparency into the utility planning process. And in Michigan, the Attorney General comments were that the commission should direct the company in its next rate case to provide a full accounting of a grid modernization project costs with sufficient detail for staff to perform a full prudency review, because they had a hard time finding the link between all of the investments and what the costs were and tracking it through the filing, which was also something that we saw a little bit of. Affordability, not surprisingly, is coming up as a common theme, as it is in almost every proceeding. This first one is an example from Maryland. BGE has also proposed more work than ratepayers should reasonably pay for. This was a discussion about prioritization and how the utility had kind of proposed everything under the sun, and the commission was criticizing them for that, and that they should do a better job of prioritizing and keeping in mind the needs of ratepayers that include affordability. And then this other example from Indiana, state policy is to protect the affordability of utility services. And this plan was more than $2 billion. This was, again, comments from the consumer advocate. The commission ended up ultimately approving the entire plan. Timing and optimization are important. This is, there was a few different comments on this one. So this first one was for Indiana, for Duke Energy. And this was the consumer advocate was commenting on how the utility was making a proactive investment proposal on DERs that was not linked to any really customer program need. And so that they were just highlighting that it would be better to wait until a customer has a specific project than to think about what this investment should be to meet those needs. In North Carolina, this is from the commission staff. They noted that they don't think that the company can execute and complete their proposal within the 3-year time frame requested. And that was something that we saw in a few other proceedings as well. Again, that was comments from the staff. The commission ended up approving that entire plan as well. And then in North Carolina, again, a similar comment from the staff. The company didn't globally optimize the project across all of the different business groups. And this kind of speaks to this idea of bringing together the different planning processes. And so there was project optimization within each one of these little silos, but not across the entire plan. And so staff were commenting on that. Some plans were rejected, or some investments were rejected because of a lack of prioritization and consideration of timing. This first one is from Maryland, and it follows up on that idea that the utilities didn't do a very good job prioritizing, and so they disallowed most of these priority 3 projects, saying that they approved priority 1 and 2 projects, but not priority 3. And then in Georgia, the commission noted that the level of DERs needed to justify a DERM system is high, and it won't be reached by the time the proposed system is fully depreciated, let alone by the end of the upcoming rate planning period in 2025. And so that was 60% of the DERM's costs were approved and 40% were not. I think this is my last slide on this topic, and then I'll get into some resources. Ongoing approval of cost recovery for grid mod technologies is not guaranteed. This is something that I found as I was going through the filings that I thought was interesting and worth taking note of. A lot of these grid mod investments are multi-year, multi-plan investments, and so they're phased. And these commissions from Maryland and also from Illinois noted that just because they approved the first phase of the investment doesn't mean that the utility gets a blank check for the rest of the investments. The utilities need to keep coming back and showing that their investments continue to be prudent, continue to be cost effective, continue to benefit ratepayers. And so both of those comments speak to that. My next slide is, this is something that you'll see for all of our presentations. These are questions that states can ask. We identified for each one of our presentations questions that commission staff or commissioners or state energy offices can ask themselves as they're thinking about the topic of the presentation. So since this one was on distribution system planning in general, first question, how do utilities in your state conduct distribution system planning? If utilities are not filing distribution plans in your state, why not? How are DERs considered in distribution planning? How's electricity load growth from transportation and buildings considered in distribution planning? Andy and I are going to talk about that tomorrow. Are SEOs and PUCs and utilities working together to maximize benefits? And are utilities' proposed grid mod investments achievable? Are they going to be able to do them in the planned period? One of the comments that I forgot to include on the slide was around staffing. I mentioned that earlier. One of the PUC staff commented on the utilities budget for labor stayed flat, but their spending went up like fivefold, and it was just like, how are you possibly going to spend this much money and implement this with the same or fewer staff, which was a pretty good point as well. And then the last question on this one is, did the utility analyze alternatives to their proposed investments and provide clear supporting information? We'll also see this on the rest of the presentations that we have today. These are actions that states can take. These are similar to the questions. What could you be doing in your state as an SEO or commission staff person, consumer advocate, to move these ideas forward, establishing clear goals and objectives and priorities for distribution system planning, as Lisa talked about, requesting baseline data from the utilities to understand the current state of distribution systems and their planning practices, having an informational proceeding to educate stakeholders on distribution planning, asking utilities to document their data inputs and outputs and metrics, analytical methods, providing guidance to the utility on using multi-objective decision analysis to prioritize grid mod and other distribution expenditures, considering development of a standard template for presenting information on costs and benefits, especially when there's lots and lots of them for the grid mod technologies, and providing guidance to the utilities on the information to include in the grid mod proposals as part of their distribution system plans. We have lots and lots of resources. Lisa highlighted some of those as she went through her presentation with the framework. This is just a sampling of some of them. This training is being recorded, as Kirsten noted. We have all of our prior trainings, or most of our prior trainings have also been recorded as well, so you can go back and check those out if you'd like and see what other topics we discussed. And that's it. I didn't bring a watch, so I don't know what time it is.